Good morning, guys. So, I wanted to address one of the most common problems from the 9-3 and 9-4 homework assignment. It had to do with entering your commands into StatDisk in order to get the correct p-value. Almost everyone had a problem with changing the hypotheses to be correct. And that wasn't just, I think, with StatDisk. I think that was also writing down the correct hypotheses. So I just want to take a look at number 9. This is about the body temperatures that are in dataset 3. And thank goodness they don't make us go in and type in all of those body temperatures. It says we get the statistics given in the accompanying table. So right over here, we have the table for exercise 9. It gives us the sample size, sample mean, and sample standard deviation for both the women and the men. Notice the women are listed first. That's a hint that we're going to do women minus men. But then it goes on to say, use these data with a 0.01 significance level to test the claim. Okay, right there, I've given a significance level and I'm saying I'm testing the claim. I'm doing a hypothesis test. That's what that's telling me. So whenever I go to StatDisk, I know I'm going to click on analysis. Of course, my computer does not want to click on analysis. And choose hypothesis testing whenever that finally will come up for me here. Oh my goodness. There we go. Okay, I'm going to choose hypothesis testing. But now I need to figure out which of these options I want to choose. And I've got a hint that it's going to be mean 2 independent samples because there's nothing indicating that these women and men are paired. But let's finish reading it. So to test the claim that women have a higher mean body temperature than men. Okay, nothing indicating that the women and men are paired in any way. So I'm thinking this is 2 independent samples. But just in case, I'm going to flip the page back over and go back to the directions. For an exercises 5 through 20, assume the 2 samples are independent. They tell us to assume they're independent, simple random samples. I'm told that from the very beginning. And selected from normally distributed populations. So that satisfies the first and third condition. Really, all I have to work to check is the second condition, the 10% condition. Okay. But again, it says that women have a higher mean body temperature than men. Women higher than men. So I'm definitely going to be doing women minus men because it was mentioned as women first in both the problem and in the table. And then if women have a higher body temperature than men, when I subtract women minus men, that should be a positive value. So when I go to write down my hypotheses, first of all, I'm going to state the parameter mu1 minus mu2 is equal to the true difference, right? Whenever I am dealing with 2 independent random samples, it's always a true difference. If they are paired data, then it's a mean difference, true mean difference. But this is not paired data. This is 2 independent random samples. So this is mu1 minus mu2. Really, I could have put mu sub w for women minus mu sub m for men if I wanted to, because that's what it means. Mu1 is going to mean women and mu2 is going to mean men. And you're going to see how I state that in a second. So mu1 minus mu2 is the true difference in mean body temperature, women minus men. That means mu1 represents the population mean body temperature for women, and mu2 represents the population body temperature for men. Okay, so I went ahead and wrote out those statistics from the table, but that's not actually required. And then I have to get my hypotheses. So my hypothesis for a difference in means is always going to be that the difference, or the null hypothesis is always going to be that difference is equal to 0. The alternative is where things change. And some of you are still struggling to get this null hypothesis down. If you know anything for this coming test, know that if you are doing a difference in means, your null hypothesis will be that the difference is equal to 0. The alternative is what can be kind of tricky and what you really have to read the problem for. So let's read that problem one more time. Again, it says we're going to test the claim that women have a higher mean body temperature than men. So really they want, and some of you wrote it this way, the answer in the back of the book writes it that way, that's fine, that mu1 is greater than mu2. Women is greater than men. Now, we want to consider how that affects the difference. So we would subtract mu2 to the other side. Mu1 minus mu2 then would be greater than 0. Because if I subtract mu2 from the right side, only 0 is left on the right side. Okay, so this is what I have to be really careful to enter into StatDisk. All right, so Let's come back over here. We were selecting analysis and then hypothesis testing, and we're choosing mean 2 independent samples. All right, now we have to enter in all our information, and it's tempting to just start with significance level, but there's something above that you have to notice, and this is where not almost everyone, but very, very many people got their p-value wrong because they left the hypothesis like this. Population mean 1 is not equal to population mean 2. The only time that we leave it like that is whenever the problem just says something about there being a difference. It doesn't give a direction to that difference. But most of the time it does give a direction. It says one is bigger than the other or one is less than the other. And in this case, it says the women's mean we think is greater than the men's mean. So we really want population mean 1 greater than population mean 2 because the population mean 1 is the women, population mean 2 is the men. So make sure you change that. And then the significance level, they said to use 0.001. Our sample size for our sample size for the first sample, which is women, is 11. Their mean, let's see, I can look back at this table here. It's 97.69. And then their sample standard deviation is 0.89. Getting that all from the table. Moving on to the men, their sample size was 59. And then their sample mean is 97.45, and their sample standard deviation is 0.66. Okay, I've got all the information I need. Notice again, I've changed my alternative hypothesis. That is the most important part. Otherwise, the p-value is wrong if you don't change that alternative hypothesis to match what you have on your paper. Now we click Evaluate. Okay, now if you didn't change your alternative hypothesis here, if you left it as this population mean 1 not equal to, let's see, right now our test statistic is 0.85. If I change it to the wrong alternative hypothesis, I get the same test statistic. That's because it finds that test statistic or the t-value for my sample results. But if I leave it as that not equal to, it multiplies the original p-value by 2, right? In this case, it would be a right area multiplied by 2 to mirror the left area, but I only want the right area. So let's make sure this is just for greater than population mean 2. Now my p-value is 0.205. Most of you got 0.41, which is twice this p-value, because again, you were doing a two-sided test with not changing your alternative hypothesis. So this is the p-value that we want. A lot of you did it almost entirely correctly, except for that, finding that p-value there. Okay, so the only other thing that I wanted to talk to you really quickly, well, there are two other things I want to talk to you quickly about. I mentioned that the directions here said that it was a random and independent sample, or that they were random and independent samples, and that the populations were all normally distributed. So the population of women's and men's, those are two separate populations, are normally distributed. But you also do have to check the 10% condition. So that the first sample size is less than 1/10 of the first population, and the second sample size is less than 1/10 of the second population, okay? Notice all I wrote for the do part, I just need the p-value. I know in our notes we wrote down the test statistic, but we really didn't need it, so I'm just writing the p-value down now. The same thing holds true for the next problem. Your alternative, actually, I want to talk about the confidence intervals first. So remember that because this is a right-tailed test, right? We're saying the difference is greater than 0. I'm not interested in if it's less than 0. I'm not interested in it not equal to. This is just a right-tailed test. I'm going to have my 0.01 on the right and a mirrored on the other side. Maybe I'll sketch this real quick for you. So I've got my normal curve. I've got 0.01 over here. Okay, this is the significance I'm talking about. If I get a sample result all the way out here, then it is a significant result. But in a normal curve, that's always mirrored on the other side. So this over here would be another 0.01. The part in the middle where I'm looking at plausible values, okay, that is my confidence level. So if I have 0.01 over here and 0.01 over here, 1 minus 0.01 minus 0.01 or 1 minus 0.02 leaves me with just 0.98. So almost everybody did a 99% confidence interval for part B when you really should have been doing a 98% confidence interval, okay? So whenever you are asked to do a hypothesis test and then also do a confidence interval on that same situation, you don't have to restate all the conditions. I just put quote marks. I'm sorry, not restate the conditions, I just put quote marks here, but in the state part, you don't have to restate what your parameter is. We already know what it is. You could just put quote marks, as long as you did, of course, state it up here. But you do have to state the confidence level, and you do have to state the name of the procedure. So then when we use StatDisk, I want you to take a look at this. StatDisk, I don't have to go through the confidence intervals, blah, 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 because it gives me that confidence interval down here, matching my alternative hypothesis, right? I said this is a right-tailed test, so it knows to do a 98% confidence interval. So if you're not sure, you could always check that too. Okay, now there's my confidence interval right there. I write it down, and then I interpret it. You always have to interpret the confidence interval. Anytime you make a confidence interval in this class, you should interpret it in confidence with that, interpret it in context with that confidence interval interpretation sentence. We are blank % confident that the interval from blank to blank captures the true, and then whatever your parameter is in context. And in this case, our parameter is difference in mean. The context is body temperatures between women and men. Please make sure you put the order correctly. If you put between men and women, that indicates that men have a higher body temperature than women, or that's what we were thinking. And that's not what we were thinking at all. It's between women and men, women minus men. I did not put on here, by the way, if you're just curious, the incorrect confidence interval for 99%. If you put this interval right here, because you did a 99% confidence interval, you at least did these steps correctly in StatDisk. To get that, you just used the wrong confidence interval. And so if you did that, I didn't take off extra points. Okay, I think that's about it. The same thing holds true for number 11. Except its alternative hypothesis should be mu1 minus mu2 is less than 0, because we're talking about these mean maximal skull breadths, and it says it thinks 4,000 is less than 150 AD. Since it mentions 4,000 BC first, mu1 represents the mean of 4,000 BC, and mu2 represents the population mean from 150 AD. So if 4,000 is less, then mu1 minus mu2 is a negative value less than 0. So again, you have to change your alternative hypothesis in StatDisk. And a lot of you didn't do that, and thus you got a p-value of like 0.00078, which is twice this p-value, which you should actually have. And again, that one had a significance level of 0.01, so you should have done a confidence level of 98% for the confidence interval. So then 9-4 only had 16 and 17. 16 was just a confidence interval, 17 was just a hypothesis test. So pretty much everybody did pretty well with the confidence interval, except for the writing of the parameter. So remember, this is paired data, so it's not mu1 minus mu2 anymore, because we don't have two separate populations, we don't have two separate samples coming from two separate populations. So we really have one population, and we're interested in these two variables, reported and measured. So mu diff is equal to the true mean difference in heights, and it's reported minus measured. Okay, notice this time it's not true difference in means, it's true mean difference, because our sample is really just those differences. In StatDisk, we actually enter the reported heights and the measured heights, but StatDisk calculates this difference between them for each value for us. Okay, so then in number 17, this is what I really wanted to talk about. Again, we have to state, this problem was kind of tricky, and so I want to explain what was going on there for those of you that got it wrong, because I think some of you will probably think that you did it right, so you won't understand your mistake. So let's look at number 17. Okay, so we're talking about the Harry Potter movies grossed huge sums of money. The table below lists the amounts grossed, during the first few days of the release of the movies Harry Potter and the Half-Blood Prince and Harry Potter and the Order of Phoenix. Now, this is very confusing of the book to do to you. It mentions Harry Potter and the Half-Blood Prince first here, but then in the table, it lists Harry Potter and the Order of the Phoenix first, okay? And then it says, use a 0.05 significance level to test the claim that Harry Potter and the Half-Blood Prince did better at the box office. So you have a choice here, but most of you chose to enter this as column 1. Sorry, I should have pointed that better. Phoenix is column 1 and Prince is column 2. And if you did that, then you are assigning Phoenix to be the mean one and Prince to be the mean two in StatDisk. But then you acted as if on your paper that it was the other way around. So you need to be really, really careful. Oh, I shouldn't have said mean one and mean two. I should have said, if you enter this is column 1 and this is column 2, then you're acting as if the difference is Phoenix minus Prince. But most of you wrote on your paper Prince minus Phoenix because Prince was mentioned first up here. Okay, I almost said mean 1 and mean 2, but that would be if they were independent random samples, and they are not independent. They are paired. Okay, so I'm testing this claim. If that's the difference, let's go ahead and look at this. The way that it's given in this data column, I'm assuming this is the first sample, say, and this is the second sample. I'm actually calculate their differences. So here is my parameter. Mu diff is equal to the true mean difference in amounts grossed. Some of you left this part out. The difference is actually in money, right? From, or during the first 10 days of release, and I put order of Phoenix minus Half-Blood Prince. Because, again, order of Phoenix is the data listed first. Okay, so then when I did my hypotheses, again, it's always the null is that it's equal to 0 for these differences. But then the alternative was that that is less than 0. Because I'm thinking, again, I want to test the claim that the Half-Blood Prince did better. So I'm thinking the Half-Blood Prince has more money. And if the Half-Blood Prince has more money, then when I subtract this will be a negative value. So mu diff will be less than 0. Okay, and you do have to make sure that you enter that correctly into StatDisk. So I'm going to show you up here where I have, I believe, entered, yep, okay. Columns 3 and 4 are the data first for Prince in column 3, and I'm sorry, I said that wrong. Phoenix is in column 3 and Prince is in column 4. So when I go to analysis, hypothesis testing, this time mean matched pairs because I actually have the data. I need to tell it column 3 is the first one and column 4 is the second one. A significance level of 0.05 is great, but I have to remember to change my alternative hypothesis. It's tempting to forget. It's not that it's just not equal to. I think Prince did better than Phoenix, so I think this is a negative value. The mean of the differences is less than 0. So when I evaluate that, you probably got the same test statistic I did, but the p-value should be 0.15404 or 405. A lot of you got 0.30, which means you did not change your alternative hypothesis to be the correct thing. Okay. All right. So I think that's about it as far as evaluating this homework. There will be at least one problem from chapter 9 on the final exam, so be prepared for that. All right, guys, have a great afternoon.